today's digital world, Android apps are expected to handle thousands, if not millions, of users simultaneously. But what happens when basic session management can't keep up? High-throughput apps like those in banking or social media face unique challenges: concurrency issues, network instability, and even the dreaded application not responding crashes. These problems can lead to poor user experiences and accidental logouts. In this video, we'll explore how to design a session management engine that not only survives but thrives under heavy load, ensuring reliability and security for every user. Scalability is more than a buzzword, it's the backbone of any successful enterprise app. Imagine a fintech platform where thousands of users log in at once. Without a robust session management system, the app could slow down, freeze, or even crash. This not only frustrates users but can also damage the company's reputation. That's why building a scalable, production-grade session management engine is essential. It ensures smooth operation even as user numbers grow and keeps your app competitive in a crowded market. Many developers start with simple session management solutions, but these often collapse under real-world conditions. High concurrency can lead to thread starvation, where background tasks get stuck waiting for resources. Flaky network transitions can cause unexpected logouts or data loss, and subtle race conditions may trigger hard-to-debug issues, like users being logged out without warning. Recognizing these pitfalls is the first step toward building a resilient system that stands up to enterprise demands. To overcome these challenges, a non-blocking architecture is key. Instead of letting session management block critical threads, we design the system to handle tasks synchronously. This means that even when one part of the app is busy, others can continue working smoothly. By separating concerns and keeping the network layer stateless, we ensure that session management doesn't become a bottleneck, even under heavy load. Network layer, often powered by OkHttp, should act purely as a transport mechanism. It doesn't store session information or handle token refresh logic. By keeping this layer stateless, we reduce complexity and make it easier to scale the app. The network simply sends and receives data, while session management is handled elsewhere. This separation of concerns is a core principle of scalable architecture. Our architecture, the SessionRepository, acts as the single source of truth for session state. This means all session-related data, like tokens and expiration times, are managed in one place. This centralization makes it easier to update, refresh, and validate sessions, reducing the risk of inconsistencies or bugs. By relying on a single source, we ensure that every part of the app has access to the most up-to-date session information. Resilient session management system separates responsibilities across distinct layers. The network layer handles data transport, the domain layer manages session state, and the UI layer interacts with users. This decoupling makes the system easier to maintain and scale. If one layer needs to change, the others can remain untouched, reducing the risk of introducing new bugs. Refreshing tokens is a critical part of session management. If done incorrectly, it can lead to security vulnerabilities or user frustration. The best practice is to handle token refreshes in the background, without blocking the main thread or interrupting the user experience. This ensures that sessions remain valid and secure, even as users move between different parts of the app. Enterprise apps often face high concurrency, with many users performing actions at the same time. Our architecture uses Kotlin coroutines to manage these concurrent operations efficiently. By leveraging coroutines, we avoid thread starvation and ensure that each session task gets the resources it needs without blocking others. This approach keeps the app responsive, even under heavy load. Race conditions occur when multiple threads try to access or modify the same data at once, leading to unpredictable results. Our session management engine uses synchronized access and atomic operations to prevent these issues. By carefully controlling how and when data is updated, we ensure that sessions remain consistent and reliable, no matter how many users are active. Kotlin has become the language of choice for modern Android development. Its support for coroutines, null safety, and concise syntax makes it ideal for building scalable session management systems. By using Kotlin, we can write cleaner, more maintainable code that takes full advantage of Android's latest features. JSON Web Tokens, or JWTs, are a popular way to manage user sessions securely. Our architecture includes best practices for storing, refreshing, and validating JWTs. By following these guidelines, we protect user data and ensure that only authorized users can access sensitive information. By combining stateless networking, a centralized session repository, and non-blocking operations, we create a blueprint for scalable session management. This approach is not just theoretical, it's been proven in real-world enterprise apps from banking to social media. With this blueprint, your app can handle growth and complexity with confidence. Session management isn't just for theory, it's essential in real-world apps. From banking platforms that require airtight security to social networks that must stay online 24/7, scalable session management is the foundation of user trust. By implementing these strategies, you ensure your app is ready for anything. Efficient thread management is crucial for high-performance apps. By using Kotlin's coroutines, we can manage multiple tasks without overwhelming the system. This keeps the app responsive and prevents common issues like ANR crashes. Proper thread management is a key part of any scalable session management engine. Background workers handle tasks like token refresh and session validation without interrupting the user experience. By offloading these tasks from the main thread, we keep the app running smoothly. This approach is especially important in apps with high concurrency where many tasks need to run at once. No system is perfect, so robust error handling is essential. Our architecture includes strategies for detecting and recovering from errors like failed token refreshes or network outages. By handling errors gracefully, we prevent crashes and keep users logged in even when things go wrong. Security is at the heart of session management. We use best practices like encrypted storage, secure token handling, and regular session validation to protect user data. By prioritizing security at every step, we build trust with users and safeguard sensitive information. Testing is a critical part of building scalable systems. We use automated tests to simulate high concurrency scenarios and identify potential bottlenecks. By testing early and often, we catch issues before they reach users, ensuring a smooth experience even as the app grows. Once the app is live, monitoring and analytics help us track performance and spot issues in real time. By collecting data on session usage, errors, and response times, we can quickly identify and fix problems. Continuous monitoring is essential for maintaining a high-quality user experience. As your app grows, so do the demands on session management. Our architecture is designed to scale seamlessly, handling more users and more data without slowing down. By planning for growth from the start, we ensure that the app remains reliable and responsive, no matter how popular it becomes. Clean architecture is all about organizing code in a way that's easy to understand and maintain. By separating concerns and using clear boundaries between layers, we make the system more robust and adaptable. This approach not only improves scalability but also makes it easier to add new features or fix bugs. Jetpack Compose is the modern toolkit for building Android UIs. Integrating session management with Compose allows for reactive real-time updates to the user interface. When session state changes, the UI responds automatically, keeping users informed and engaged. Kotlin coroutines are a powerful tool for managing asynchronous tasks. In our session management engine, coroutines handle everything from token refresh to session validation, all without blocking the main thread. This keeps the app fast and responsive, even during complex operations. Sessions don't last forever. Our engine includes logic to detect when a session is about to expire and refresh tokens automatically. This proactive approach keeps users logged in and prevents interruptions, even during long app sessions. A great session management system is invisible to users. By handling sessions efficiently in the background, we ensure that users can focus on what matters using the app. Smooth transitions, instant logins, and zero interruptions are the hallmarks of a user-focused design. Validating sessions is crucial for security. Our architecture includes checks to ensure that every session is valid before allowing access to sensitive features. This prevents unauthorized access and keeps user data safe at all times. Users often switch between Wi-Fi and mobile data or move through areas with poor connectivity. Our session management engine handles these transitions gracefully, maintaining session integrity even when the network is unstable. This ensures a consistent experience, no matter where users are. Performance optimization is an ongoing process. By profiling the app and identifying slow spots, we can make targeted improvements. This keeps session management fast and efficient even as the app evolves and grows. Logging and auditing are important for both security and troubleshooting. Our engine records key session events, making it easy to track down issues or investigate suspicious activity. This transparency helps maintain trust and accountability. Many users access apps from multiple devices. Our session management system supports seamless multi-device access, ensuring that sessions remain consistent and secure across phones, tablets, and more. This flexibility is essential for modern apps. Dependency injection simplifies the management of complex systems. By injecting session management components where they're needed, we reduce coupling and make the codebase easier to test and maintain. This approach is a best practice in modern Android development. Session timeout policies help balance security and usability. By setting appropriate timeouts, we protect user data without causing unnecessary logouts. Our architecture allows for flexible timeout settings tailored to the needs of different apps. When a session is about to expire or needs attention, user notifications keep everyone informed. Our system sends timely alerts, allowing users to take action before being logged out. This proactive communication improves the overall experience. Sometimes, sessions end unexpectedly due to network issues or device restarts. Our architecture includes recovery mechanisms that help users quickly regain access without starting over. This reduces frustration and keeps users engaged. Storing session data securely is a top priority. We use encrypted storage solutions to protect tokens and other sensitive information. This ensures that even if a device is lost or stolen, user data remains safe. Every app has unique requirements. Our session management blueprint is flexible, allowing for customization based on business needs. Whether it's stricter security for banking or seamless access for social apps, the architecture adapts to fit. Building a scalable session management engine is an ongoing process. By gathering feedback, monitoring performance, and updating the architecture, we ensure that the system stays ahead of new challenges and continues to deliver a great user experience. Clear documentation and training are essential for maintaining a complex system. By providing guides and resources, we help developers understand and use the session management engine effectively. This ensures consistency and quality across the team. Staying up to date with community and industry standards helps keep your session management engine modern and secure. By following best practices and learning from others, we ensure that our architecture remains relevant and effective. Leveraging open-source tools can accelerate development and improve reliability. Many libraries and frameworks are available for session management, token handling, and security. By choosing well-supported tools, we build on the work of the community and avoid reinventing the wheel. Technology evolves quickly, so future-proofing your app is vital. Our session management architecture is designed to adapt to new requirements, technologies, and user expectations. By building with flexibility in mind, we ensure long-term success. Let's recap the essentials. A scalable session management engine relies on stateless networking, centralized session state, non-blocking operations, and robust security. By following these principles, you can build Android apps that perform reliably, scale effortlessly, and keep users happy. Ready to implement these strategies? Start by reviewing your current session management approach, identify areas for improvement, and gradually adopt the best practices we've discussed. With careful planning and execution, your app will be ready for enterprise-scale success. Designing a highly scalable, production-grade session management engine in Android is both a challenge and an opportunity. By embracing modern architecture, best practices, and continuous improvement, you can deliver secure, reliable, and seamless experiences for every user. Thanks for joining us on this deep dive into Android session management.